Hello everyone, it's Alexis. Today we're going to be going over the extended Bohr model. So with the Bohr model, we already know that E total equals negative RH Z squared over N squared. But this is only for one electron atoms. For one electron atoms. And this list is quite short. So we have hydrogen, helium +1, lithium 2+, and so on. So in order to account for all the other atoms, we have the extended Bohr model. And in this, Z effective, which is the nuclear charge the electron really feels, replaces Z. So our equation turns into E total equals negative RH Z effective squared over N squared. We also had another equation for the radius, and previously this was R equals A naught N squared over Z. But now we can replace our Z with Z effective to give us R equals A naught N squared over Z effective. So with our new equations, we can show an example of how this impacts it. And for today, we're going to do an example with fluorine and lithium. And we're going to rewrite our equations in terms of a proportionality relationship. So we have E total is proportional to Z effective squared over N squared. And we also have R is proportional to N squared over Z effective. So we're going to have to look at the Z effective for both fluorine and lithium. So we can remember from the previous video that Z effective equals Z, the protons, minus S in perfect shielding. So for fluorine, the approximate Z effective is 9 minus 5, which gives us around 4. And then for lithium, we have a Z effective approximately 3 minus 2, which gives us an approximation of 1. So now we have our approximate Z effective of both fluorine and lithium. And now we can look at our proportionalities. And first we're going to look at E total. And we can see that E total is directly square proportional to Z effective. And we are going to look at it in terms of absolute values of E total. And we can see that a larger Z effective then will correlate to a larger magnitude of the E total. So fluorine, which has a larger approximate Z effective, will have a larger magnitude of E total. And we will write that in. So the absolute value of the E total of fluorine is greater than the absolute value of the E total of lithium. And now we're going to look at the radius. And the radius and Z effective have an inverse relationship. So now the bigger the Z effective, the smaller the radius. And we can see that fluorine again has a bigger Z effective approximate than lithium. So the radius of fluorine is less than the radius of lithium. And this is pretty crazy because fluorine is much more massive than lithium. Fluorine's atomic mass is 18.998 grams per mole, and lithium's is 5.941 grams per mole. So it's over double the mass of lithium. But when you look at the actual radii of each, you can see that the radius of fluorine is about 1.4 A0, and the radius of lithium is about 3 A0. So the radius is over double that of fluorine, and that is all because of the Z-effective. Thank you for watching the video. I hope it was helpful, and I'll see you next time.